All right, this is the quiz 3 review. We're going to be going through every question on quiz 3. I've gone ahead and listed some of the steps that you're going to be using for finding the median or the first quartile or the third quartile, depending on the question they're asking about. So these 6 steps are really important because, one, you're going to need them for this quiz, and I guarantee you there's going to be 1 or 2 questions that are asked like this on the actual exam. So be wary of that. Is that this type of question definitely has always shown up on exam 1 every single semester for the last 8 semesters, guaranteed. So if you don't commit these to memory today, just bear in mind you're going to need to commit them to memory later on, or follow these steps on some sort of cheat sheet that I give out to you. By the way, you will be given a cheat sheet for exam 1. I dropped it in the GroupMe a few days ago, but because I don't know if you downloaded it or it wasn't easy to download from GroupMe, I'll be sending it so it hits your inbox. It'll be hitting you, the email you signed up with. It'll be hitting your inbox, so you'll have a cheat sheet on how to do, I would say, 80 to 90% of the problems on exam 1. Literally study that cheat sheet and you should be golden. Make sure you know how to do the problems using it as well. The nice thing about being able to take these quizzes or these tests online is that you're allowed to use your notes to do them. So that makes things super easy. That was not the case prior to taking these classes online, was that when you went into the exam, there was no cheat sheet you could bring in with you. So it's such a nice blessing that you guys get to use one when you take these tests. All right. Number 1, in 2019, what percentage of unemployed persons reported a spell of unemployment of 15 weeks or more? Cool. Well, I'm going to check out the table back on the second slide, or depending on whether you're looking at the Canvas page or the PDF. I'm looking at the PDF. So the second slide has the table of the different people who are unemployed of 16 or older, as well as the years under which they had this duration of unemployment. We're looking for in 2019. So we're going to look in that first column, 2019. What percent of unemployed persons reported a spell of unemployment lasting 15 weeks or more? So we're going to look at the first 4 cells, 38, 34.8, 29.8, 14.3, and 21.1. We want to know 15 weeks or longer. So when we're looking at 2019, let's go ahead and draw this. Why not? 2019, we have 34.8. We have 29.8. We have 14.3, and we have 21.1. And then these durations, let's put this in green, less than 5, let's say 0 to 5, 5 to 15, 15 to 27, and 27 and beyond. Okay, we want to know what percent of people had 15 weeks of unemployment or more. Well, that would be these 2 people, or these 2 groups of people. Let's add those percentages together for 35.4. As a percentage, you're going to leave it right just like that, 35.4%, and that is your answer to number 1. All right, let's do the median calculation. It says calculate the median duration of unemployment in 2010. So I'm going to go ahead and throw in 2010 in there as well. Here's 2010 over here. 18.5, 21.0, 15.6, and 44.9. I would grab a calculator for these steps as well. You don't have to have one, but it certainly makes it easier. I would highly recommend doing it or having a calculator with you. When you go to do these steps, so we're going to find the median. Step 1 says starting from the top, add the percentages in each cell moving down until the sum is larger than 50%. For our purposes, we will call the cell containing the last percentage we added this way the target cell. So for instance, I'm going to start from the top and take 18.5. 18.5 by itself is not larger than 50%, so I'm going to keep adding. 18.5 plus 21.0, that's 39.5. That is not yet bigger than 50%, so I'm going to add the next percentage. I'm going to add the 15.6. So adding these numbers up gives me 55.1. So this is my target cell because it's the last cell that I added before the percentage was bigger than 50. Okay, so step 1 is done. That's my target cell. Step 2, find the running total of percentages before adding the target cell. So what I mean by that is just add everything up to, but not including the target cell. So that's going to be 18.5 plus the 21.0. That gives me 39.5. Step 3, subtract that result from 50. So I'm going to take 50 and do minus 39.5. That's going to give me 10.5. Okay. Step 4, divide that result by the percentage in the target cell. So I'm going to take 10.5 and divide that by the 15.6 in my target cell. This comes out to be, let's do this, grab calculator, see why it's important. 10.5 divided by 15.6 gives me 0.673. We'll go to 3 decimal places. That should be good enough. Step 5, multiply the result by the width of the interval adjacent to the target cell. So what do I mean by that? So we're going to take the 0.673 we just got from step 4 and multiply it by the width of the thing adjacent to the target cell. So the width of this interval is just the upper bound minus the lower bound. So 15 to 27 has a width of 27 minus 15 or 12. That is the width of that target cell, or the interval adjacent to the target cell. So we'll do 0.673 times 12. 0.673 times 12 gives me 8.076. And then step 6 says, add that result to the lower endpoint of the same interval. So I'm going to take 8.076, and I'm going to add that to the lower endpoint. The lower endpoint was 15, so we'll say plus 15 to get an answer of 23.076. They say round it to 1 decimal, so we'll say 23.1. Any questions on how I did that? And please ask, because I'm going to be doing this 3 or 4 more times for the rest of this quiz review. So make sure you understood every single step. Take the time to give everyone the 5-10 seconds to think it over. I'm going to also double check my answer. So I checked my answer. I got 23.076, which rounds to 23.1. So it seems good to me. Any questions on that? Okay. We're going to do it all over again. They want us to do it again, but for 2015. So I'm going to undo all that stuff. 2015 numbers, let me go ahead and write those up here as well. 2015. We've got 28.9, 27.7, 15.3, and 28.1. I want the median again. So if I start by adding the cells together. Notice the first cell by itself, 28.9, is not bigger than 50. But then I'm going to take 28.9 and add 27.7, and that gives me 56.6. So this time, this is my target cell. I have already crossed the threshold of 50% by virtue of adding the 27.7. So 27.7 is my target cell. Step 2, find the running total of percentages before adding the target cell. That was only the 28.9. That's the only thing that we added so far. So 28.9 is your answer, step 2. Subtract that result from 50. 50 minus 28.9 is 21.1. Divide the result by the percentage in the target cell. So I'm going to take that 21.1 and divide by 27.7. 21.1 divided by 27.7. That gives me 0.762. All right, now I'm going to multiply that result by the width of the interval adjacent to it, adjacent to the target cell. This is 0.762 times the width of this interval. This interval is not the same interval, so bear in mind it's not a length of 12 anymore. Distance from 5 to 15 is 10. That makes it pretty easy to get, so I get 7.62. And then I'm going to add that to the lower endpoint of the same interval. The lower endpoint was 5, so I'm going to take 5 plus 7.62. Gives me an answer of 12.62. Any questions on that? And then one more time. So 12.62, by the way, was your answer to, I think it was number 3. Yeah, number 3. We're going to do it one more time, but we're going to find the median for 2019. 2019, start by adding the cells until such a time as we cross the threshold of 50. This cell by itself doesn't cross the threshold of 50, but adding these two cells together does. So this is my target cell. The running running total of percentages before adding that target cell is 34.8. That's the only cell that would have been added before adding the target cell. Subtract the result from 50. So 50 minus 34.8 gives me 15.2. Divide that result by the amount in the target cell. So 15.2 divided by 29.8 is going to give me, grab a calculator, I get, my calculator's thinking about it for, I'm using them. Okay, I don't know why it's giving me issues. Oh, there we go, 0.51. Okay, step 5, multiply that result by the width of the interval adjacent to the target cell. So 0.51 times the width. This interval is from 5 to 15. That's the one had a width of 10. So we get 0.51 times 10. That gives me 5.1. And then we're going to add this to the lower endpoint of the target cell, or the same interval. So we have 5.1 added to that lower endpoint of 5 gives me 10.1. This is your answer to 4. Okay, that all seem reasonable? This calculation, you're going to be almost guaranteed to be asked this calculation on your first exam. At least it has been that way for the last 8 semesters since 2017 or probably earlier. You've been asked to do some sort of calculation where you find the median from some table of data. Okay. Here's how she might mix it up. She might ask you to find a quartile, like the first quartile or the third quartile. That really doesn't change too much. Here's how it changes your steps. So now I'm going to change the steps a little bit to modify what they are going to be for the first quartile. Okay. So watch carefully. This is now 25%. This is now 25%. That's the only changes that have been made. Now they are for, these are the instructions for finding Q1 or the first quartile. Okay. The only thing that changed in doing so is that instead of this saying 50%, it says 25%. And same thing here. Instead of saying 50%, it says 25%. The method, other than that, is exactly the same. So they want us to do that for first quartile of 2010. So I'm going to take 18.5%. That by itself is not bigger than the desired 25%. So we're going to stop. We're going to keep going. 18.5 plus 21.0, you can bet sure is bigger than 25%. So this is our target cell. Because 18.5 plus 21.0 crosses that finish line of 25%. Find the running total percentages before adding the target cell. Well, that's merely the 18.5. That was the only cell that would not have been added to the target cell, or only be added before adding the target cell. So 18.5. Subtract the result from 25. So 25 minus 18.5 gives me 6.5. Divide this result, divide 6.5 by the amount in the target cell. So divide by 21. This comes out to be, okay, for whatever reason, the web calculator is having an issue. There we go, 0.309, we'll say 0.31. Okay, multiply that by the width of the interval adjacent to the target cell. This is still the interval that has a length of 10. So 0.31 times 10 gives me 3.1. Then we're going to add that to the lower endpoint of the same interval. So we get 5 plus 3.1, which is 8.1. Okay, that was the first quartile for 2010. We're going to do it again, but for 2019. I'll point out that for 2019, this one's kind of interesting. The first, we would take the percentages and add them until we cross 25%. Well, notice that the first percentage is already bigger than 25%. So this is our target cell. Our target cell is the 34.8 because it already is bigger than 25%. Step 2 says find the running total of percentage before adding the target cell. That would be 0. Nothing's been added because there's nothing prior to the target cell. So you would say the running total prior to adding the target cell would be 0. Subtract that result from 25. That one's pretty easy. 25 minus 0. You don't need a calculator for this one, or at least I hope you don't. 25 minus 0 is 25. Then we divide that percentage by the result in the target cell. So 25 divided by 34.8. That gives me 0.718. And then I'm going to multiply that by the width of the interval adjacent to the target cell. This target cell's interval is 0 to 5. So that's a width of 5. So 0.718 times 5 is going to give me 0.718 times 5 gives me 3.59. And then you add this to the lower endpoint of the same interval. The lower endpoint this time was 0. So it's just 0 plus 3.59, which is 3.59. So this is your answer to number 6. Number 7, also not that bad. Number 7, pretty quick and easy, because they want you to do the third quartile. Well, guess what? If the first quartile was 25%, the third quartile is 75%. Okay? Calculate the third quartile in 2019. We are going to add these percentages until such a time as we're bigger than 75%. So this plus this is not yet 75%. I don't think 34.8 plus 29.8 is. Why is this calculator so slow? It's addition. It can't be that hard. 34.8 plus 29.8, grab the phone, 64.6, okay? And then add 14.3. This gives me 78.9. 78.9 is indeed bigger than 75. So this number was the last number I added to get me 78.9. So this is my target cell. Step 2 says find the running total of percentage before adding that target cell. So that'd be 34.8 plus this 29.8, which comes out to be 64.6. It's getting kind of repetitive now, right? Subtract that result from 75, because this is the third quartile. 75 minus 64.6 is 10.4. Divide that result by the percentage in the target cell. 10.4 divided by 14.3 equals 10.4 divided by 14.3. Should have known better than to use that calculator. Divided by 14.3. I get 0.7272. We'll say 727. Multiply that amount by the width of the interval adjacent to the target cell. So this interval goes from 15 to 27. So we're going to take that 0.727 and multiply by 12. I get 8.724. And then we're going to add that result to the lower endpoint of the same interval. I'm going to take the 8.724 and add it to the lower endpoint of 15, giving me 23.724. Times 12 plus 15 gives me, I want to make sure, 23.724. We'll just say 23.7. By the way, I know that when I've been doing this, I probably haven't been rounding to 1 decimal. You should do the same. I don't know if she would take points off. I don't know how Canvas works in terms of like, I think it is a stickler for the answer. So make sure you're rounding all the last answers that we just did, numbers 1 through 7. All of those get rounded to 1 decimal. I think if you do more than 1 decimal, it yells at you and gives you no points. So be wary of that. Give the value of the interquartile range in 2019 based on your quartiles. Okay. Someone's gonna have to remind me what my quartile was for what Q1 was. So we have 23.7 there. 23.7, Q3, 23.7. Because someone will remind me what Q1 was. What was our answer to number 6?
3.6.
3.6. Your interquartile range, IQR, is just Q3 minus Q1. So 23.7 minus 3.6 comes out to be 20.1. Just want to double check that. 25 over 34.8 times 5 plus 0. 3.6, yeah, okay. 20.1 is your interquartile range. Any questions on that? Okay. Suppose you were graphing the relative frequency. Okay, we're done with all this stuff. We don't really need this anymore. I'm going to leave this stuff up here in case you want to look at it some more. But now we're talking about the height. So the formula I use for height of desired rectangle equals, it looks like a long formula, but only requires 3 numbers. It is percentage of desired rectangle. Let's say desired interval equals percentage of desired interval times width of narrowest interval. I'm going to change the font size here. Divided by width of desired interval. So in our case, it says, what height would you use for rectangle over the interval 5 to 15 in 2019? Okay. Let's just take the numbers that were given to us and plug them into the formula. We have what percentage is that interval? So this is the 5 to 15 interval in 2019. 29.8. By the way, I was going to say when you do this, you should use a decimal, but not just ignore that. It's going to be 29.5. That's, or 29.8. That's fine. Times the width of the narrowest interval. Well, what's the width of the narrowest interval? Looking at all the intervals above, we've got an interval that goes from 0 to 5. That's a width of 5. This interval goes from 5 to 15. That's a width of 10. This interval goes from 15 to 27. That's a width of 12. So out of the intervals we have, and this one goes from 27 to wherever. So that's the longest interval. But the narrowest interval seems to be this one, the one that has a width of 5. So we're going to put a 5 here. And then divided by the width of the desired interval. What do I mean by the desired interval? Well, what interval are we looking at? We are looking at the interval going from 5 to 15. So that interval has a width of 10. So your answer ends up being 29.8 times 5 divided by 10, or times a half. It gives you 14.9. And so that's what we would be. That would be our answer to number 9. We're going to do the same exact thing for the next question. Number 10 says, what height would you use for the rectangle over the third class interval? Same formula. What's the percentage of the desired interval? Well, this time we're talking about the third interval, the one going from 15 to 27. This percentage is 14.3 times width of the narrowest interval. The narrowest interval is still 0 to 5, and it still has a width of 5. But what does change is the interval we're looking at. This interval goes from 15 to 27, so we're talking about an interval length, or width, whatever you want to call it, of 12. So our answer ends up being 14.3 times 5, but divided by 12 gives me, all right, 5.96, but we're going to 1 decimal, so we'll say 6.0, because I guess 5.95, the 5 rounds up to a 0, and the 9 rounds to the 0, so the 0 rounds to a 6.0. So 6.0 is what I guess you get for number 10. We've got 5 questions left. Let's knock these out. The mean durations reported in the table. Let's practice calculating the mean from group data. Calculate the mean duration. So here's how you do mean. Let's delete some of this stuff. Step 1, let's do these steps. Step 1, find the midpoint of each interval. Step 2, multiply the midpoint by each percentage, by its corresponding percentage, written as a decimal. It's an important part we'll talk about in a second. And then add these up. There's not as many steps. Add these all up. So it's only a 3-step process. I don't know why these are written so weirdly, but okay. Step 1, find the midpoint of each interval. We're doing this. Oh, and by the way, it says that assume the upper end of the highest interval is 52 weeks. So let me clean this up a little bit. 52 weeks. This now says instead of being 27 plus, it's 27 to 52. Okay. Step 1, find the midpoint of each interval. I mean, I'm surprised I had to say this because I did last semester. If you're like, how do you find the midpoint? And I was like, okay, Come on, it's like an OU question. Don't say that. Anyway, midpoint would just be to average the lower and upper endpoints. So just add them together and divide by 2. So 0 plus 5 divided by 2 equals 2.5. 5 plus 15 divided by 2, that's 10. 15 plus 27 divided by 2, that's 21. Yeah. And then we've got 52 plus 27 divided by 2. Gives me, I think it's going to be 39.5. Yeah. 27 plus 52 divided by 2, 39.5. Okay. Step 2, multiply each of those midpoints by its corresponding percentage written as a decimal. So what do I mean by that? Well, they wanted you to find the mean duration of unemployment in 2019. So we're going to be focusing on the 2019 column. Make sure we're focusing on this column. I want you to multiply each of those midpoints by these percentages, but those percentages should be written as a decimal. So what I mean by that, I mean when I say do x bar, you say x bar equals 2.5 times not 34.8, but 0.348. In a similar fashion, I don't want you to do 10, because that's the next midpoint, times 29.8. Don't say 29.8, say 0.298. Plus the next midpoint is 21. And then the percentage associated with that would be 14.3, but I want it as a decimal, so 0.143. And lastly, plus 39.5 times its percentage or midpoint, or its percentage as a decimal, so 0.211. So 2.5 times 0.348 plus 10 times 0.298 plus 21 times 0.143 plus, I need some parentheses there, plus 39.5 times 0.211. And this gives me, it's crazy that this happens. I'm going to use this. 15.1875. That should at least be somewhat close to the value they gave in the table. They gave the mean as 21.6, close enough. It's the reason it's not close is because the upper bound has not been capped, and there are people who are unemployed for longer than 52 weeks, but we'll talk more about that in a second. So I guess rounded to one decimal, you want 15.2. So I want to double check the number again because I feel like I might have fat fingered something. So 2.5 times 0.348 plus 10 times 0.298 plus 21 times 0.143 plus 39.5 times 0.211. I get 15.18, which rounds to 15.2. Any questions on number 11? Okay. In 2010, the mean calculate, I'm not even going to read the paragraph. There's something they say that is relevant there. I'll address it in a second. In 2010, the mean duration calculated from raw data was 39.9 weeks from the table above. If the modification had been in place in 2010, would the mean have been bigger, smaller, or the same? So the modification they're talking about is you could only report unemployment up to 2 years. So for instance, if you were unemployed longer than 2 years, you still only said you were unemployed for 2 years. So even if you were unemployed for 10 years or for 5 years or for 6 years, you still said you were unemployed for 2 years. What is this going to have on what effect will this have on the mean? So throw it to the audience to try and figure out. So right now, so in 2010, all you could say, the biggest number you could say was 2 years. So 24, or I guess not, see that 150. So I guess in weeks that would be. So you could only say 104 weeks unemployed. They later made a modification that allowed you to say you were unemployed up to 5 years. So let's see, 260 weeks. Because of that modification, what would happen to the mean? Well, now we're including people who might have reported a longer unemployment duration. Because they can report a longer duration for unemployment, what would that do to the mean? Make it bigger, smaller, or stay the same? Wow, you guys are real bold. No one in the chat wants to say it. I see like all I see.
Smaller?
Nope. Good guess. Thanks for going out on a limb, but no. So let's put it this way. I'll give you an idea. Right now, we've got people who say 5, 10, 20, 30, and the highest they could ever say they were unemployed for was 104. So let's say you got these couple of guys who said, I've been unemployed for 2 years. I don't know what the mean of this set is. Let's just say it's, tell you what, for the purpose of this explanation, I'll calculate it. 5 plus 10 plus 20 plus 30 plus 208 is 62, 68 plus 5, 273. For the love of, I hate this calculator. There we go. Nope, it's pulling up something on the internet. I don't want that. I want you to just add the numbers for me. 273, okay. 273 then divided by 6. So 273 divided by 6 is 45.5. That's the average. Okay. Now, the Bureau of Labor Statistics says you can report answers longer than 104. Now you can give answers like 211 or answers like 192. What is that going to do to the mean calculation? Is it going to make it bigger or smaller?
Bigger.
Bigger. Yeah, that's it. That's all the question's asking. So the answer to 12 is bigger. In 2010, the mean duration was 39.3 weeks, but if the modification being that you could report a longer duration of unemployment, what would have happened to the mean? It would have gone up. How about the median? Guess what? The median doesn't change. So let's do the same thing. I'm gonna do another extreme example. Ready? 1, 2, 3, 4, 5, 6. And let's say the highest number someone can say is 7. Okay. I want someone to be super brave, unmute themselves, and tell me the median from this set. So it's not like the usual calculation of the median where I use those crazy 6 steps or whatever. Don't worry about that. Clark. 4. That is the median. Okay. Keep yourself unmuted. Got a follow-up question for you.
Okay.
I'm going to change it. So now I'm going to say you can change it so that the biggest number you can report is 700. Okay. Now what's the median?
Still 4.
It's still 4. Okay. With that in mind, you can mute yourself now. Number 13 says, what would the median have been if we had done the modification where you can now say you're unemployed for longer than 2 years? The median would have been the same. So the mean goes up, but the median stays the same. That's all that's being said by this modification. Okay. Number 14. Suppose the table above had an additional class interval at the upper end. So instead of 27 to 52 weeks, we also had 52 to 104. I think this is the same idea. Imagine recalculating the median from the group data in 2010. What would the median be? Same idea. Okay, well, now we're just taking this percentage. This was 2010, right? So we had 44.9%. I don't know what the breakdown is of percentages for 49%. Maybe it was 21% here and then 23.9% here. I don't know what they are, but guess what? The median was still in this bucket anyway. The median was still, I don't remember what the number was. It was something like a 21 point something or 23 point something. Well, whatever our answer to number 2 was in the bucket from 15 to 27. Now the question is, if we throw in an additional like interval down here, how does it change the median? Guess what? It doesn't change it, because again, the steps for finding the median would be to say, add the cell values until such a time as the sum is more than 50%. Once it's more than 50%, that's your target cell. Then I'd take the running percentage sum, subtract that from 50, divide by the percentage in the target cell, multiply by the width of the interval, and then add that to the lower endpoint. Guess what? The fact that I have some additional rows down here doesn't change our answer. So your answer to 14 should be stays the same. The median will stay the same, even with the additional grouped data. So we're just adding numbers toward the tail end that are big. Like, and again, the example I just used, I said the upper value was 7, the median was 4. Okay, now I'm going to say the upper value is 700. What's the median? It's still 4. Okay, and the last question is pretty easy. We don't even need anything else for this. Let's just talk about data and how it's shaped. We're going to talk about 3 different graphs that we'll call today. They're really easy graphs. Boom, boom, boom. This is symmetric. This is right skewed. And this is left skewed. So what are the rules here? The mean is about the same as the median. Right skewed, mean is bigger than the median. And then in this case, this is left skewed. We'll talk about that in a second. Mean is smaller than the median. And we call this symmetric. We call this right skewed or positively skewed. And we call this left skewed, aka negatively skewed. Now in our case, it says in 2019, the mean is bigger than the median. Okay. Additionally, the distribution was unimodal. From these facts, we can conclude the distribution which of the following. The unimodal part just says there's one hump. These all have one hump, right? One hump, one hump. Well, stop. One hump, one hump, one hump. So it doesn't matter that it's unimodal. But the fact remains is that the mean is bigger than the median. Because the mean's bigger than the median, what is the skew or the shape of our distribution? It will be positively skewed. So that's your answer to B. Okay. Was there a... That was the last one, right?
Yes.
Cool. Is there anyone brave enough who wants to hit submit on their answers and tell me they got 100? And if they didn't, we have to figure out where I went wrong. Clark, I think you were the brave guinea pig last time, so you don't have, doesn't have to be you.
I'm okay doing it.
Cool.
So,
Sure.
yep. Yeah, we're good.
Girl, good. 100 out of 100, or however
Yep.
many points it was. Cool.
Mhm.
Excellent. Like I said, we do these review sessions every Monday. When there's a quiz due, sometimes we'll be doing 2 quizzes at a time because there gets to a point in the semester where there are 2 at a time. Be on the lookout for the exam 1 review because that will be coming up shortly. I know that the quizzes are, I'm sure you're worried about those and doing those, but the exam reviews are also going to be, make sure that's I think 25 or 20% of your grade. So can't afford to screw that up. We'll be doing that in a few weeks, and then be on the lookout for more of these quiz reviews. You can book me for private tutoring if you want. If you have a bunch of friends that want to get together and say, hey, listen, I want to do a group session, cool, we'll do one of those. But for now, we're just going to keep it to these quiz sessions and the exam review. But yeah, reach out to me and we'll set something up if you want to do some private tutoring. I'll see you guys next time, and we're going to start the recording here.